Hello everyone. So today our topic is Mosfet. So what is Mosfet? A Mosfet is a field effector transistor where the voltage determines the conductivity of the device. It is used for switching or amplifying signals. The ability to change the conductivity with the amount of applied voltage can be used for amplifying or switching electronic signals. So now the structure of Mosfet. So MOSFET is a four-terminal device with source, drain, gate, and the body terminals. The body is frequently connected to the source terminal, reducing the terminals to three. It works by varying the width of the channel along which charge carries flow, which is mainly of electrons or holes. The charge carriers enter the channel at the source and exit via the drain. The width of the channel is controlled by the voltage on an electrode called gate, which is located between the source and the drain. It is insulated from the channel near an extremely thin layer of metal oxide. The metal the metal insulator semiconductor field effect transistor is a term with synonym of MOSFET. Now, different types of MOSFET. So MOSFET works into two modes, depletion mode and enhancement mode. In depletion mode, the transistor requires the gate source voltage to switch the device off, and the depletion mode of MOSFET is equivalent to normally closed switch. In enhancement mode, the transistor requires a gate source voltage to switch the device on. The enhancement mode of MOSFET is equivalent to normally open. And now further, with respect to the working principle, MOSFET can be classified into another four groups: P-channel depletion MOSFET, P-channel enhancement MOSFET, N-channel depletion MOSFET, and N-channel enhancement MOSFET. P-channel MOSFET. Now in P-channel MOSFET, the drain and the source are heavily doped with P region and the substrate is in N-type. The current flows due to the flow of positively charged holes, and that's why it's known as P-channel MOSFET. When we apply the negative gate voltage, the electrons present beneath the oxide layer experience repulsive force and are pushed downwards into the substrate. The depletion region is populated by bound positive charges which are associated with the donor atoms. Now, N-channel MOSFET. In N-channel MOSFET, the drain and the source are heavily doped with N region and the substrate is P-type. The current flows due to the flow of negatively charged electrons, and that's why it's known as N-type channel. When we apply the positive gate voltage, the holes present beneath the oxide layer experience repulsive force and the holes are pushed downwards into the bound negative charge which are associated with the acceptor atoms. The positive gate voltage also attracts electrons from the N source and drain voltage region into the channel, and thus an electron-rich channel is formed. Now here there's the transfer characteristics and output characteristics of the p-channel enhancement MOSFET, and this is for the n-channel enhancement type MOSFET for the transfer characteristics and output characteristics. Now coming to MOSFET working operation. So here the working principle of the MOSFET depends upon the MOS capacitor. The MOS capacitor is the main part of the MOSFET. The semiconductor surface at the below oxide layer is located between the source and the drain terminals. It can be inverted from P-type to N-type by applying positive or negative gate voltages. When we apply positive gate voltage, the hole present under the oxide layers experience a repulsive force, and the holes are pushed downwards with the substrate. The depletion region is populated by bound negative charges that are associated with the acceptor atoms. The electrons reach and the channel is formed. The positive voltage also attracts electrons from the N source and drain regions into the channel. Now, the characteristics of MOSFET. So, as you can see, it is tri-terminal, unipolar, and controlled by the voltage. It also has high input impedance. Now, the operating regions of MOSFET. So, it has three operating regions, that is cutoff region, ohmic region, and saturation region. In the cutoff region, this is the region in which there will be no conduction and due to which MOSFET will stay off and behave like an open switch. In the ohmic region, the current gets increased with an increase in its voltage value, and MOSFETs are used to operate in this region and are generally used as amplifiers. Now, third, saturation region. In this region, the current stays constant even with the voltage increase. This occurs only when the pinch of voltage value of the voltage increases. In this region of the MOSFET works as a closed switch. This operating region is only used when MOSFET is required to work switching operations. Now, MOSFET can be used as a switch. So let's see how it can. Now, MOSFETs can be used as switches to control the flow of current. When the gate voltage is zero, the channel is not formed and no current flows between the source and the drain. And when a positive voltage is applied to the gate of N-channel MOSFET, a negative voltage is applied to the P-gate MOSFET and the channel is formed and the current flows between the source and the drain. Now, MOSFET as an amplifier, in as MOSFET can also be used as amplifiers to increase the strength of the signal. When the small voltage is applied to the gate, it can produce a large change in current between the source and the drain. This property makes the MOSFETs very useful in electronic circuits. Now coming to advantages and disadvantages of MOSFET. So in advantages, it is used to work at greater efficiency but with a lower voltage value, and it has no gate current. Due to this, it gives a high input impedance which produces a high switching speed. Now coming to its disadvantages, it is susceptible to damage due to its thin oxide layer, which can get damaged because of electrostatic charges. It also gets unstable when the voltage gets overloaded. Now the last part, applications of MOSFET. So in application of MOSFET, MOSFETs can be used in various places, such as in electronic DC relays, in DC motor drives. It is used as a high frequency amplifier. It is used as an inverter in digital circuits. It is also used in uh, uh, passive elements like inductor, resistor, and capacitors, etc. So that's all from my side. Thank you.